In March 2026, NASA revealed an ambitious new plan for the future of American space exploration. On the surface, this is a blueprint for colonizing the moon, which is incredible. But the even more important revelation is that NASA itself has fundamentally changed into something that the world has not seen in decades. And the reason for this change goes deeper than just new leadership. There is a great power competition that will play out on the moon in the decade to come. The old NASA was set to lose that contest, but the new NASA is playing to win. And this is how they're going to do it. When Administrator Jared Isaacman took the stage at NASA headquarters in Washington, D.C., there was one simple word projected on the screen behind him: ignition. That word announces the beginning of a transformative journey for the American space program. The status quo has been rejected and replaced with a new direction to set high expectations and then meet them. Isaacman acknowledges that for decades, NASA has been spread too thin. They've tried to make everyone happy and in the process have accomplished very little. The result has been billions of taxpayer dollars wasted and years of progress lost. He also made it clear why that change must begin right now, because there is more to lose than just time and money. There is a great power competition with the Chinese to stake the first permanent claim on the moon. And this is nothing like the space race the world saw before in the 1960s. But this time, the goal is not flags and footprints. This time the goal is to stay. America will never again give up the moon. Now, we have heard these words before from NASA administrators and politicians over the past decades, but words are hollow without actions. And historic actions require intelligent plans, which is the one thing that NASA has lacked since the very beginning of the Artemis moon program. Better late than never. A detailed, achievable step-by-step blueprint for the Artemis moon base has finally arrived. And it all begins with a complete overhaul of the moon landing schedule as we have come to know it. For the first big change, there will be no boots on the moon for Artemis 3. This has been reformatted into a dress rehearsal mission that will play out in low Earth orbit. Now, this probably sounds counterintuitive to everything we just said, but it's not. Because the old plan had a jump from Artemis 2, which is a crewed test flight of the Orion spacecraft, to landing on the moon using an entirely separate and unproven HLS vehicle. This was an unachievable goal, and the risk factor was so high that it never would have gotten off the ground. So the launch date became a can that was kicked further and further down the road with every year that passed. Under the new direction, Artemis 3 will instead feature the crewed Orion spacecraft and the lander vehicle meeting up in low Earth orbit for a rendezvous and docking procedure. The crew will then transfer into the lander for a test of the life support, communications, and propulsion systems. If possible, they'll also test the new lunar EVA spacesuits inside the lander airlock for the first time. Doing this in low Earth orbit means that problems can be solved and lives can be saved if anything doesn't work as expected. We already know about the Orion spacecraft, but this new moon lander is still a bit of a question mark. For many years now, this was assumed to be a lunar variant of the SpaceX Starship, but now that is not so certain. Isaacman has confirmed that Blue Origin is back in the race alongside SpaceX with their Blue Moon lander, and one or both of these vehicles will be tested on Artemis 3. It all depends on who can get the job done in time for launch. This is a big aspect to the new direction at NASA. Even SpaceX can be put on notice. Just because you won a contract in 2022 does not mean you are guaranteed a moon landing. The only thing that matters now is execution. And the first company to achieve their goal will be the one who sends American astronauts back to the moon. The deadline for Artemis 3 has been moved up to next year, 2027. And then, once the new lunar lander is confirmed, the winner will be expected to keep moving at incredible speed. They now have only a few months to test their vehicle in an uncrewed moon landing and then turn around a completed design for Artemis 4. This mission is now scheduled for early 2028, and this is when America returns to the moon with a landing in the South Pole region. But like Isaacman said, this is not about flags and footprints. So to make their point clear to the world, NASA will land people on the moon again in 2028, with Artemis 5 scheduled before the end of that year. Now, that sounds overly ambitious, but this is how NASA used to operate in their golden era. The turnaround time between the first moon landing on Apollo 11 and the next landing on Apollo 12 was just 120 days. And this is more than just a flex. This will set the new tempo for American moon landings, with a crew arriving on the surface once every 6 months from here on out. This is also where NASA's commitment shifts to establishing their permanent outpost on the moon, and that begins with prioritizing surface operations over everything else. So, the Lunar Gateway space station that was originally planned to orbit the moon, that's no longer on the table. But it doesn't mean that time and resources spent building the gateway have been wasted either. All of the hardware that has already been developed for the station is being repurposed into the design of the first moon base.
The construction of that base will happen over 7 years, and NASA has set themselves a budget of $20 billion to get this done. It all plays out in 3 phases, and this starts right now.
Phase 1 covers 2026 to 2028. And the primary goal over this time is to secure reliable access to the surface of the moon with a high launch cadence. That means sending 25 missions in the first 3 years, with 21 of those being lunar landings. 2 of those will be crewed missions, but the majority of this phase is about experimenting with new technologies for the future moon base operations. This includes sending nuclear power to the moon. There is a sunlight problem up there that needs to be solved, and nuclear energy is the only way to do it. The day and night cycle of the moon is a lot longer than what we know on Earth. So the Artemis base will experience 2 weeks of continuous sunlight, but then it will be plunged into another 2 weeks of darkness. During that time, the temperature will drop below negative 200 degrees C, and without a source of heat, all of the hardware will freeze solid. That tends to be really bad for electronics, and they typically don't come back to life when the sun rises again. So NASA's going to experiment with radioisotope thermal generators. Basically, you have a radioactive element like plutonium that is actively decaying. That process naturally releases heat, and this heat can be captured to prevent assets on the moon from freezing solid. What kind of assets are we talking about here? Well, NASA has a radical new idea for exploring the moon: rocket drones. They call this new vehicle Moonfall. It's based on the Ingenuity Mars helicopter platform, but instead of propellers, it uses small rocket thrusters to move around. Each drone can fly for 150 seconds in one hop and cover up to 50 kilometers distance. They are going to use these to explore dangerous and hard-to-reach locations like tops of mountains and edges of deep craters. During Phase 1, NASA will also deploy their Viper rover. This is a golf cart-sized vehicle that is already built, tested, and has been waiting for a ride to the moon for years. 2027 will finally be that year. Viper will arrive at the moon on a Blue Origin lander. Once there, it's going to begin mapping the South Pole region for confirmed signs of water, ice, and other volatile materials like hydrogen, oxygen, and rare earth metals. NASA considers this to be lunar prospecting. Establishing the locations of these resources will be critical when Phase 3 comes around. Viper will be joined on the ground by 2 lunar terrain vehicles, one to be driven by the crew members and one that drives autonomously. Each rover will be able to cover up to 900 kilometers of the lunar surface. And beyond just exploration, they'll be used for work purposes like moving equipment and leveling ground for new construction. Overhead will be a new group of lunar communications and observation satellites. These will allow continuous data streaming from any location on the moon to the surface of the Earth with a 500 megabyte per second throughput. They'll also provide a continuous view of the entire lunar surface from space. Now, this is very important to us, as in you and me, because NASA has mandated that all of these vehicles we just mentioned, the drones, the rovers, the electric cars, they are all going to be equipped with high-quality cameras that will live stream their entire mission back to Earth for everyone in the world to see. That sets us up for Phase 2, the transition into building a moon base. This plays out from 2029 to 2032. It involves 27 launches and 24 landings, and includes the first infrastructure for permanent habitation modules. Over this time, NASA will deliver 6 new rovers, and these go beyond just exploration. NASA is talking about excavation in this phase, machines that can move rock, level ground, dig trenches for power cables and pipelines. We are building the foundation for things to come. One of these new rovers will also be the first pressurized mobile habitat. It's a vehicle being developed by the Japanese Space Agency in partnership with Toyota. The 15,000 kilograms vehicle will essentially become an apartment on wheels. Astronauts inside will be comfortable enough to hang out in short-sleeved t-shirts and will travel at a speed of 3.5 kilometers per hour for days on end. The rover is expected to have a 10 28-year lifespan and will operate for up to 150 hours in total darkness. Phase 2 will also demand more power than ever before, and that comes in two flavors. The first will be solar energy. Solar panels will be mounted on top of long poles to capture as much sunlight as possible, and they'll be connected into large battery systems for long-term energy storage. That is going to be supplemented with nuclear power, and this goes beyond just keeping things warm. NASA will deploy nuclear fission reactors to the moon that generate hundreds of watts of electricity and supply multiple assets simultaneously. By the end of Phase 2, everything will be in place to support people living on the moon for extended durations. Now, Phase 3 is where we actually move in. This covers everything from 2033 onward, and the highlight of Phase 3 will be permanent habitation of the Artemis moon base. NASA projects that they can have a rotating crew of 4 people staying on the moon for 28 days on a single mission. People will be living in multiple connected modules, basically a space station like the ISS or what Gateway was imagined to be, except built on solid ground. The habitat modules will be powered directly by their own nuclear fission generator and will be supplied with around 8,000 kilograms of food, water, and air every month. Outside of the base, NASA will begin their first in-situ resource utilization. That means harvesting rock and soil from the environment and using it to their advantage. Water can be extracted from ice reserves in the bottom of shadowed craters. The water can be split into oxygen to breathe and hydrogen to use as fuel. NASA is also going to start experimenting with 3D printing, taking dust from the surface and melting it down into a portable cement that will eventually build the first genuinely permanent structures on the moon. Now, if you're thinking that this sounds like doing the impossible, then you are not crazy. NASA has admitted that what they are trying to achieve is very nearly impossible, but that's kind of the point. We're not doing this because it is easy, but because it's hard. The Chinese are also fully prepared to do hard, nearly impossible things. These are the stakes of the new space race. Good enough is no longer good enough. And NASA knows something now that they've been missing for a long time, because the real key objective of this whole Artemis plan isn't actually to build a moon base. The real imperative is to inspire the next generation of scientists and engineers, the young people who will accomplish things in their lives that we would genuinely believe to be impossible today. But those kids will never do that if they don't have the motivation to go out and make it happen. It's NASA's job to lead by example, and they haven't been doing that for a very long time. But the future is finally back on track today. If you want to see a vision of what NASA's city on the moon will look like beyond Phase 3 of the Artemis plan, then click the box on the screen right now.